Good evening, everyone. I am Rajasri Roy Choudhury, Data Science and AI Intern at Labmentix. Today is my first project presentation on the project of PhonePe Transaction Insights. I am going to present my project, and I was told to do the presentations in Zoom, but because of some technical issues, I couldn't do it. So, I am doing the presentation in Google Meet. From next time, I will try to do it in Zoom. Here now I'm going to explain the entire project that I have encountered and solved. This is the problem statement first. So this is the project title and this is the problem statement. So in short, if I explain what exactly the question or the project what we have to do in this project. In this project, we are going to have a big data set, and it is a PhonePe data set, okay, which will contain some information about transactions and all those insurance transactions, and from what regions people have made transactions. And it will also going to have some data about uh, what category of transaction people has made, like through cards or through UPIs, like that, whether the transaction was success or failure, like that. Also, so much data about transactions will be there, which is beneficial for a company like PhonePe a lot. So on those data, we are going to study the data, and with our codes, we are going to manipulate the data and going to solve some case studies with certain scenarios and going to analyze them, with first getting some better insights, which can also be very beneficial for a bigger company like PhonePe. Like if we are studying the data and finding out some important insights, like if I find out in the insight, like we are going to see it in the later case studies, but I am just trying to say it in a summary in the beginning just. For example, uh, if in a place in a rural area there is lack of transactions, then PhonePe must understand that there is some issues among the people and there is not much awareness among the people about the knowledge of transaction. So maybe PhonePe need to do some more campaigns, and they need to I mean need to put effort and invest some way to makes the weaker region better also, and also the stronger points that already the in using PhonePe and online transactions. So for them also, like more they have to, like they have to maintain that strength. Like in the Bangalore, the metropolitan areas, in those places it is very much common to use online transactions. So PhonePe need to maintain that strength point also. So they need to analyze these things so much. So, and obviously they cannot study person by person. So it is a insight that I got through my project, that in the entire project, we might think as a beginner there might be data of a human, like how a human do a transaction. It's more like a group data is given, like state based or district based. With that, like that, we have to encounter the data and in order to solve the question properly. So let us first see the data. I already opened the data is given in the GitHub format. Okay, so this is the data given. Okay, let us first see the structure of data, because understanding the structure of data is very much essential, because when we have to do the codes, like in the codes we have to reach to the data. Like this is not a direct CSV file given to us. It is more like a GitHub link is given, and from that GitHub link we need to fetch the data. In short, so we need to understand the structure in order to write the proper Python code, like so that we can in like, because there are so many files. I'm just showing, like in this data file we are going to find our data. So this is the first staircase we crossed. After that we have three main folders of data. One is aggregated, one is main, and one is stock. So we don't have any idea what data can be present into that these three of the folders. So let us first start with aggregated. In the aggregated also, see there are three more folders. So we can just guess something about that. This is about insurance data, this is transaction data, this is something about the user, some data maybe. Then we are just opening another folder. here also inside insurance also there are certain data about years. So we cannot assume again. We just have to open the data. So into that we found some JSON files. That means one insight that we got in order to attack the data, in order to write a proper code to fetch the data, that these are JSON files. And number two, what are the hurdles we have to cross in order to reach the data? Like first we have to, I will explain it in the while in the coding. Or let's see that only first. This is the code portion. So this is the first thing. How we are going to link the collab with the GitHub. Like as I told, the data is in the GitHub. So I need to connect the collab somehow with the GitHub. So how? So we can just make a GitHub repository, like clone, GitHub clone. We can just make the clone of the GitHub repository with which we want to work. Like we want to work with this PhonePe GitHub repository, right? So we are just making a clone of the GitHub repository like this in this format. And like the what is happening in short is in Labmentix, it is just getting connected with the Google Colab. So after that, my first approach is that, like as I know, the first thing is that the data is in the data is in JSON format. So I am not really like it's very important for us that when we are encountering a problem, it is not always that we are going to feel comfortable in that field of work. So I know I am comfortable in working with CSVs, but here the thing is given that JSON. So in my mind, the thing that came to encounter is that I can convert the two ways. One, I can just pass the JSON files that can be, but as I told, I'm not so comfortable in JSON. So I can do one other thing that after getting the data, like after crossing all these folders, like it is not a direct data. We have to cross all these folders and need to understand the relations among the folders. Otherwise, there can be a problem also. I will explain all that. So here, I can convert a JSON files to CSV. That is one idea I can give. But that is, we cannot do that blindly. We need to understand the structure of JSON first in order to convert it to the CSV columns, because CSV has lots of columns, like it is like as in Excel sheet. So let's first open the JSON file. In the JSON file, we can see that like this some data is present. Like we don't have enough idea like what the data is about. We only know it is about transaction something. So upon that idea, we can say that this success to means we can say if a man is trying to do some transaction, maybe the transaction is a success. So the thing is written success to. This code is given. So we can assume from this code that okay, if the transaction is successful, the code is given is success. After that, what happened is that this data is given from to. So from my experience in this project over this time, one thing I understood, I got the insight is that this is Unicode characters of date. If you search in Google, you will find that these are just dates, but in Unicode way. So this thing we understood that this is a date or the time, date and time within which this transaction is done. Like we are just assuming, we are not so sure about it now because we need to build the columns in order to turn the JSON into CSV. So that is the thing. Even though we are not directly doing the JSON parsing for the ultimate project, but we are doing some sort of JSON parsing in order to get and work with the JSON file and then converting it to the CSV file. So then we are getting the name, like for what reason the transaction is done. That is insurance. For the insurance matter, the transaction is done. Like category, we can also name its category, like what category of transaction is it? Is it you what's the reason? Like loan or investment or insurance, like that. So this is insurance. And then lot other data is there, like type, like is it the partial transaction, like sometimes we put advance money, then we sometimes we just pay the total money. So this is a total amount of money. Then we are counting like number of transaction. So here we can guess, like can one person move so many number of transactions? That can be a question, like count. So So an amount, like amount here, it is again in Unicode character. It is like a huge amount. So and this is a timestamp. So one thing we can understand that maybe it is not a transaction of one person. It is maybe transaction of a group. Like it can be a state of a people of an entire state or people of an entire country, but or maybe people of entire city or district also. Yeah. So now we are going to enter into the code first. So we also what the columns I build is that I want to show the study of the columns. See, because how I got to understand that these are the columns I need to work on in order to, because the JSON file is kind of complicated to parse. So I need to structure them in some columns first. Then based on this column, I can turn it to CSV. Because if the idea is coming that exactly whatever the things that here like success code like these are we are going to turn into column, that is very much wrong, because that will not going to give us a very proper understanding of the data. We need to use some brain here. So this is the thing. For the aggregated column, one thing we understood that this is an overall idea, giving us an overall idea about the transaction. Like as I told, even the state is not given in the question. Still, we can assume that it is a collective data of states or country or district, something like that. So we can take the column even though we put all nulls there. So let us see what are the columns we're working in. So only insight we got from the aggregated column is that this column is all about the entire data about the transaction, or it gives us the summary about the entire process of transaction. Like, so let's see. Category. Category is the like type of service because of which the transaction is happening. Like recharge or UPI transaction. That is the thing. Then payment type. Payment type means in what mode the transaction is happening. Like in UPI mode or in cards or in debit, like in the debit card, credit card, all those things, or in wallet. And then comes transaction count, like number of transaction took place. Like in the JSON file, you also saw these two amount, transaction count and transaction amount. These two are same. Then here is the year and quarter files. Here the year is all about the time. Remember it showed that a timing is there. That range of timing from and to that we gave here. See, from date to date. That part of data will be here. And here we have taken a year in order to do the further analysis later on. And the quarter file actually work like when we are going to parse the data, like I felt it was important. Later on, it was not so important, I felt, but I just kept it because as I saw that in all the data, I will just show the data first now. Here, see, in all of this data, like in aggregated column, in aggregated data, suppose all this has the same pattern. Like for this data, JSON 2, JSON 3, JSON 4. Like in JSON file, numberings are there. Then if I see the next data of insurance, suppose 2021. So here is also JSON 1, JSON 2, JSON 3, JSON 4, like that. Again, let's see some other data. Like if we open any of the yearly data, we can see this JSON 1, 2, 3, 4 thing. Even in some other data also, like suppose if I see the insurance we have seen till now, if we see the transaction data, here also see so many years. And one thing to notice, in the previous file of insurance, our data were from 2020, year 2020. But here, see the data is starting from 2018. So we need to keep in mind, like this is what happens when you observe the data properly. We get a proper idea about the data. Like here, the data are from 2018 till 2024, and there is another state thing. We are going to come later on this. So and previous data was also till 2024. So here also see in the transaction data also there is JSON 1, 2, 3, 4. Like this, we understood one thing is that in all of this JSON 1, 2, 3, 4 is there. So in that file that I initialized by the name of quarter files, I am just storing the name of this, whether it is JSON 1, JSON 2, JSON 3, or JSON 4. I just feel it can be important, but later on it didn't need it. So, but these practices might help later on some other different kind of problem. So the map data means that this is what we worked on, the aggregated data. And another thing in the aggregated data, here I have saved, yes, in the aggregated data, see, I have given this state name. You may ask that, yes, like, why to put the state name? In that data, there was no states. This is the point. In this aggregated data, the see, in each of this part, insurance, transaction, and user, there is a folder name that is static. After all the yearly data folders, there is a folder called state. See, in that state, there is all states of India. And what is there inside? Inside each of these states, there are again some years. Within those years, there is again some JSON files. So, like, this is why it is so important to study the data, because we need to understand where exactly my JSON files are present in order to get those JSON files. So, see, what is the structure? Let us just summarize the structure. That first we are getting into the main folder, then within the data. Within data, we have three main folders, that is aggregated, map, and top. And within each of the folders, like I have studied this, that all of these three folders have the structure, same structure. That is, I'm just saying it first, then I will show. Number one is the individual folders, like aggregated, main, and top. Once we get inside them, we are going to have some three folders more, that is insurance, transaction, user. Like, see, in the previous also, in the map also that is same. See, in the map folder is same, insurance, transaction, user. Let's check out the top also. In the top also we have insurance, transaction, user. So this is same. That means we can repeat the same coding in these three cases, at least in this portion, because we need to find the similarities in order to make the code easy. So after we get into any of these folders, like insurance, suppose, we can see there is years along with state. So another understanding is there. When we are entering any of these inner folders, insurance, transaction, users, within them there are sets of years, and there is a state folder. And when we are opening the year folder, in the year folder, the JSON files are present. See, JSON files are present. And within the state folders, let me just say first, within the state folders, there are again some years, and within those years, the JSON files are present. So this structure is very much important in order to understand and parse this entire thing in order to write the code. See, one mistake I said, I told that within the state there will be some years, then the JSON file. No, that was wrong. Within the states folder, there will be the states. Number of states will be there. All the states of India will be there. Then within that, the years will be there. Within that, the data will be there. So this is so important. And this is same repeated for all the things, like all insurance, transaction, user of aggregated. Similarly, same for map and same for top. The same structure is repeated. So this part is a similarity we can understand. But now the main coming, when I'm trying to parse the JSON file particularly, for the aggregated we understood the main thing. But for the map, what is the structure of data? Let us first see. This is the, this is the data. So this is the data of the map folder again. Here, because see, in the aggregated, even though there are different other fields like insurance, transaction, and user, the format is generally same in the aggregated. So I am not repeating the same thing again and again. In the map folder, see, the thing is again, the success thing is there, code is there. There's something is meta, like data level, like, okay, here's something we need to work with countries and all other percentiles and grid levels. So this data is very much big actually. Here latitude, longitudes are also given. So from the map, and what is this telling name of the states and all are also given. So from here, the insight that we got is that from the map folder, from the map JSON file of map, my screen got blank for a moment. So this is the map data. In the map data, we need to take into account that the important columns on which we are going to work with, there is the important part is first of all latitude, longitude. Like we saw just now, we saw the important parts are latitude, longitude, and metric. Metric means what, like based on what we are finding the transaction, like whether the transaction we are getting, like as I mentioned, this is not individual transaction, it can be either of state transaction or district transaction or country transaction. Like that is the metric I am trying to say, that state is a metric, country is a metric, like that basis I am trying to say. Label, now label is being more specific, like name of the place or region, like this is now coming to the main district name or the state name, or the in the previous metric we are just saving whether it is a state or district, but in the label we are going to save the name of that place, like district, the place name of the district or name of that state. In the subfolder we are going to indicate for uh, the like user type, like what type, in what way the user did the transactions, and again the years and the quartile files. Quartile file means the JSON numbering, like 1.json or 2.json, like that, and year means the normal. Here the year is again there, and this is all about the map file, and I'm just explaining the top data here also because it is nothing different. In the top data we are going to see more about the entity types. Entity types means like in the top data the main purpose of this data is that to find the topmost, suppose topmost 10 cities where the transaction is more. So in order to find the topmost places where the transaction is more, certain factors are needed, like whether based on pin codes or districts or anything. So that is the entity type. Then again the transaction count, like number of transaction took place, or the what is the transaction amount, because that is very important metrics for ranking and all. And then there is a metric type, like means we studied in the previous part, like what is the metric type means. So and then entity types, like entity types means like who are doing the transaction, whether it is common people or a company. Then if it is a company, then who is the company, like here it is told like entity type was the one which was telling us who was doing this, like company or individual, like district, pin code, or brands or company. The company will be here, but in the entity name, here will be the name of the entity. Like if it is a district, then what is the name of the district? If it is a pin code, then what is the pin code? If it is a brand, then what is the brand? If it is an app, then what is the app? So here, entity name, the names of those entities will be there. Then year and quartile file is again the same. Quarter file is again the same. So this was all about understanding the data. Now we are going to enter into the coding part, which is the main part of this. Till now was important portion, because without understanding the data, these projects are not understandable. The codes are not understandable. So first, what I am trying to do is that, sorry, so this is the first code that we worked on. In this code, see, we have tried to convert the entire aggregated data into the in the aggregated folder. The data in JSON, we tried to convert it into the CSV. And in the aggregated folder, as per we saw, there are three sections: insurance, transaction, and users. And within them also there are the JSON files with states file, and all the JSON files were in yearly manner, yearly, like year 2018, 19, 20, all like that. And along with them, the states were also there. All states of India were also there. So based on the study, this is the way I have divided the columns into. And after I did that, uh, I'm sorry, the screen is hanging. Like first, what I did, first I did the country level data, okay, without considering the state that isolated. Then I considered state level data because I just broken the problem into this part because handling the total problem was getting so hard. I don't know why my let me first. This is, I don't know. It is just getting slided too much. Sorry. Okay. Now, this is a state level data we work. Like first, I work on the I divided the problem into two parts. One in country level data, one is state level data. In the country level data, I showed the columns. Now this is a state level data because we just now saw in the data that in the states also so many states are there, and within the states our ERs are again there, and all the JSON files are there too. So I felt if I divide the state level data into different parts, it will be more easier to handle, and it really became easier to handle. So this is how I handle the again this I use the same columns. I use the same columns for the entire aggregated file, aggregated folder, and after that I like printed, downloaded the combined the combined CSV file got came here like aggregated folder. Then I just did is that splitted the elements into insurance. I don't know. It is not being shown here, but I'm showing. Uh, Here is the dataset. So the CSV file that I downloaded from the collab is that after I did the entire code, working on the entire thing was good. Like I got the combined CSV, but I need to work on the individual things. Like on the insurance file, I need to do the analysis upon the insurance file, transaction file, user file of all these three folders, the aggregated, map, and top. So for that, I needed the individual files. So that's what I did. I made, I don't know why it is happening, but okay, here I did. I have repeatedly saved the CSV files of insurance and transaction and user like this, and I'm just showing. And the same thing I did for uh, metadata, map data, and also same for the top data. And only the columns are different. The way I explained the columns in the previous Word file, in the same way I have splitted the column. This is for the map data. See the longitude, latitude, and all these things that here. I explained why I wrote it like this, and again splitted it also. Like this also I have did in the same way, like in the country level first, state level first. That's why I first told understanding the data is important so that we can find a pattern in order to solve the problem. And after that, again I splitted it into three parts. Yes, wait. Yes, I splitted it into three parts, like insurance map, insurance.csv, insurance map.csv, transaction map.csv, and user map.csv, because it is of these are the insurance transaction and user of map folder. Okay, previous was of aggregated folder, and in the same way, but the columns are different as we study in the data. I also did same for the top folder as well, and here are the folder names. In the same way, I just divide into country wise and state wise, and then within that, based on the columns, I decided I just parsed the data and converted to CSV. That first I got the combined CSV, and after that I splitted them into splitted into the individual CSV of insurance, transaction, and user. And now here I did a mistake. I just kept the mistake in order to uh, for my proper understanding. Now after I did with this parsing and fetching the data, like I will just like to show the data. Like in these three files, aggregated, map, and top, I have saved my data. Here are my all data in CSV format. And after I did this, my then work is to do the SQL queries in order to do the case studies. Like I cannot do the case studies like that. I need to need to first convert this CSV into the tables. So first I kind of tried to do that thing in the Colab file, that converting the CSV to the SQL tables. But as in Colab, from Colab, like my all the data are present in the local files, and my SQL is in my local computer. So from Colab, it is not possible to reach to my SQL server. So it is not possible to do from Colab. Wait. So this part of, not this part, sorry. Yes, from this part. That previous part was splitting the data of top into three of CSV. From here, I wanted to show. Now, from this part, like from pip install pandas, SQL, alchemy, MySQL, this part is so much needed for converting the CSVs to the SQL tables. But this part is okay. After this, the code that comes here, this part of code is not for the Colab. Here, what I did is that it is my username, it is my password, it is my host. In order to connect with the SQL server with Python, we do this entire syntax, and this I just renamed the CSV files with a certain easier names in order to do the things more easily. But this is not supposed to be correct if we do it from Colab. We are supposed to do it from our local machines only. Wait, I'm trying to show. Yes. Here is my code for CSV to CSV to SQL. I will just start it now. So this is my code. First part I already explained, like we are just importing the important libraries. Then in order to connect with the SQL, MySQL server, these are the for authentications, these are needed. And then I am just from we're just saving it into the variable CSV to table, all the CSV names. And here in this site, and yeah, in order to do this, we have to upload all the CSV files here. Like I did it here. See, I already in aggregated map and top, I have uploaded all the things so that things can be, yes. See, all the whole CSV files are here, and from that I have here all the links, path links are given of each CSV, and I have mapped them with a name I am trying to give it to it. So this is the way I have mapped them, like the path of the CSV file with a certain name I am giving to them. Then actually in my computer there is less space, so for that the program was failing again and again. So I just divided it into the smaller chunks, so that at a time on my CPU there is not so much pressure. So that's why in thousand chunks of thousand I have divided the entire size of the data of CSV, and then I uploaded it to the MySQL. And yeah, that's it. And these two transaction top and user top, I was having some problems, so I separately upload it in the MySQL in the same way, in the exact same way. I did no changes there. So the same code is there, just it is for the transaction top and this user top. Now let us see the MySQL queries. These are the MySQL queries. Like first, before all of this, because of the previous code I did, all these tables got saved. Like all these tables on the most left hand side, most all these tables got saved because of the code that I wrote in that VS code. So this was the main functionality of the VS code, those codes in order to save these steps. Now when I have all these tables, like I created a database named PhonePe DB, and based on that, now I have written the queries upon the case studies now. So like first I will have to show the case studies. So first case study one is that now I am going to explain the case studies and analysis side by side. So in the case study one, we are decoding transaction dynamic on PhonePe. Like what is happening here? Let's see. I have made a document on this also so that I can explain it properly. So this is the given case study that was given in the question, that it was, sorry, yes, it is given in the question that all these things. So in my point, like, what is the main thing I am asked? I am asked that, like, PhonePe is a big company and it has, like, a big company has a lot of competition. So as a result, in order to do more innovation, or in order to improve in their field more, they need to know the trends of the people around in order to understand that what is, on what point they can improve, or what are the stronger points that they need to enhance more. So based on that, they need to understand the payment styles or payment types, based on different factors like state, in each state how the things are there, also yearly how the things improving or decreasing, or what are the payment types that are around the in different places, like whether at a particular place the payment type is only cash, or there is some online transactions happening. If there is more, then why? If there is less, then also why, in order to do more improvement in the field. So I couldn't find the, okay. Now my case study that says that what I did, like what is my approach in the case study, how it is beneficial in order to align with this scenario, that I first grouped the transaction by each of the state names yearly, and what are the payment types of them. Because as I told, for PhonePe, it is really important to check out the transaction, how the transactions are going state to state, like in order to find the trend. And along with seeing the trends in each states, they also need to find the analysis as per years also, and also as per payment types also, as I explained. So I grouped all of this, and as per that, I did the first case study. And what I did, I first did all the grouping of all these columns, and then I sum them up in order to get the transaction count and amount. Now, I will like to show my analysis to show, means this part is all about the analysis that I will show. Yes, here is my analysis for the first case study. This is the case study 1. Before, I just did some certain important files. Here I just imported the important CSV files on which I will be working. And after that, yes, what files I have uploaded here, that is the important thing. So these are not the CSV files that I previously worked on, or the from the previous part of the code that I downloaded. No, it is not that. Like, previous part of the code means after doing the parsing from the JSON, the CSV file we got, just that is, these are not those files. What are these files then? Here, after doing the case study, as I explained in the case study 1, what I did. After doing all those grouping and summations of the important factors, I got this is the table I got. This is the table I got, and this table I exported with the name I wanted. And those this case, after the case studies, the table we got, we uploaded those tables in the Google Colab, and on those tables we have performed the analysis. So this is the first understanding. So this is the case study 1. This is the graph of case study 1. It says, like, what insight we can get from this graph. Number in from this insight, we can see that yearly the transaction amount is increasing, and that is a very good thing. Like, the trend is that year-wise the transaction, the payment type is increasing, and yeah, and it is a total payment. And now comes the case 2. This was the case. Yeah, I have mentioned the case 3 because as per the given question, this is case 3. Means we are told to do 5 case studies. So I did case 1, case 3, case 4, case 6, and case 7. Overall 5 cases I did. So as per the question number, this is case 3. So in this, what we have to do, let us see from the word file again. Here it is about insurance penetration and growth potential analysis. So in summary, if we have to understand like what is the thing we are exactly trying to do, it is that uh, like uh, like insurance is like also money related thing where obviously phone plays a very important role. So in that matter, PhonePe need to, in order to expand this field of insurance, they need to understand the trend first. That whether this trend of insurance is where it is high, then there is more demand is there. They need to provide better service to those places. Like identify the higher performing and lower performing states in order to provide proper services. And after that, it is not only about services where there is low performance are there. Those places they have to provide proper marketing and partnerships in order to attract more customers and let people know that how much this insurance thing is beneficial. So how my case study is important here again. So in my case study, I group the data by state names, years, and I use the quarter file data. I felt that the JSON files tracking will be important in some ways, but it was not so important. So we can ignore the quarter files, but the main part important is that I have grouped the state names and the years, and then sum up total the transaction count and transaction amount for the insurance. And after that, what I did, this is again analysis part. In the analysis part, we got what are the highest, like what places are the highest value. So this, as I told in this part, the main aim of PhonePe is finding the high performance part and low performance part. So it's the high performance part. So I'm just showing the analysis. This is the case study 3 that I discussed, and this is the analysis. Oh, it's a big graph. So this is the total transaction, and on the y-axis it is the state names and top 10 states by total insurance transaction. Here I have plotted. So from here we can understand the highest performance places to the comparatively lesser performance places. So next comes the case study 4. Case study 4, it is about market expansion. From here, then from the name we can understand market expansion means again here the main aim of the PhonePe is all about expanding the market in order to understanding the trends. I'm just trying to show that part also here. So here again it has to find the regions with the highest growth or what part are overperforming, and if the parts are some underperforming, then how to help them out. In order to that, identification is very important, and also to find the expansion opportunities, because sometimes if the weakness can be caught, there can be some very good opportunities for expansion. So that is the thing. And after that, uh, then I have did here I have used lag function in order to calculate the quarter over quarter growth. And here the analysis I did. In the analysis, what I did is that here in case study 4, I have did two graphs, two case studies I did. So this is the result of the first case studies, like year wise, how much transaction is happening. Like it is showing that graph as per each state, like year versus state. In x-axis the year is there, in y-axis states are there. And after that, in the second graph, like the top 5 states with the highest quality of growth in transaction, like for which I have used the lag function I told in order to find the quarter by quarter improvement growth. So for, here in this part 2 of case study, we have used that. Then comes the next case study, that is, oh, I have also, like as well, I told that the important is also the top high performance places is important that I have shown in the above. Also the lower performance places is also important in order to find the weaknesses. So I have also found the lower performance states that have lower performance in transaction, because it can give a proper insight to the company to work in a different way to find better opportunities. Now case study 6, insurance engagement trends. In the insurance engagement trends, here here again, they have to understand the trend in order to find the stronger regions of user engagement, and also to find to grow the potential, means where there is growth, means potential for more growth in insurance, and to put efforts in them. And here how we can do that, like if we study state by state, how much each state's having the improvements or any lag yearly, then we can find this and do the study of this very properly. So that's what I did here, is that here I have shown the insurance engagement yearly with each states, how much yearly the amount is actually increasing, not states, insurance amount, with total insurance amount I have worked with. So this is the and then I found the top states with high insurance, like invested amount in means more insurance. What are the states like Karnataka, Kerala, Maharashtra, Tamil Nadu, and Uttar Pradesh? These are the states with the highest amount of insurance over the years. So this is the study. This is a very important study. And after that, the last case study comes, case study 7. Here I was told to do transaction analysis across states and district. It is very simple. Like across the states and district, we have to find the analysis and do the case studies. So again, it is more about regional. So as it is regional analysis, the case studies is all about finding the top 10 state, but by this time it is by transaction amount. Like previously we were doing the insurance thing. Here the state versus the transaction values we did, and upon that we did the analysis and we got the top 10 states in terms of transaction. So it gives a insight, more better insight for the company to about the stronger regions with what amount of insurance or what amount of among that transaction, what part is of insurance. They can calculate the percentage and all other things in order to calculate even churn rate. They can also calculate from that. And after this thing, as our project analysis is completed, then I have did the streamlit portion to visualize it. So first we have to install the streamlit, and after that, here for streamlit, the code we have to write in the VS code. Like this is the code I have written. This is the streamlit code I have written here, and this code file just I had to upload in the Google Colab, that and with exclamation line ls. I can see all the files that are there, and after that we have to install this, because previously I tried to do the streamlit, some errors came, and these installations are important. Otherwise, streamlit performance was getting deteriorated. So yes, I'm sorry, things are hanging. So after that, this okay, this thing is very important. I was not aware of this thing actually. When the errors were coming, I understood like first we have to make an account here, and uh, yes, in this website we have to make the accounts and okay. And here from the auth tokens, we have to copy the auth tokens, authentic tokens, so that we can run our Streamlit somewhere, right, in a platform. So in terms of authentication, to get that security, we use this NGRK platform. And here I have just given the authentication token that I just now shown. And after that, I have just imported the Python code that I have written in the VS code. Wait, I'm trying to show. Yes, here. Here I am just imported some important libraries to avoid some uh, bugs. And here I have I cannot show it, sorry. Here, um, here is the Python file that PhonePe analysis app py. This is the file that I have. This is the file that I have wrote in the VS Code and uploaded in the Google Colab, and this is how I wrote the code. And after that, when I run it, the streamlit website has appeared. I don't know after so many time connecting the session it will open or not, but let's try. Should open. It's not opening because of the session has ended. I have to run everything again, so it will take time. So I have already, let's see if it opens. Uh, let's try the streamlit portion. Let's run this part only. Okay, it ran because it was taking so much time. So I thought maybe if I will keep it run already. Okay, okay. Okay. This is the interface we first encountered. Then we have to the visit site. Here in the visit site, we can see the entire dashboard. Uh, let me make it small first. Sorry. So can you move it? Let's just keep it here. So this is the first analysis my dashboard of PhonePe, and this is about the case study one that I did the visualization. This is the case study one. Here we can analyze as per the years. I have kept all the years in order to show it. After that, as I work with the case study 3, it is a little bit slow. For some reason, the net is so slow and it is hanging a lot. Now it's working. Yes. This is the case study 3, and this is a dynamic dashboard again. Like it's showing the insurance data. Like this is the case study 3, insurance penetration and growth. If we can manipulate the data, see the it's dynamic. Like state we can see from here. Like state name is Karnataka, and what is the total insurance transaction we can see from here as well. If we make it little bit less, the data will see the data got changed. And if we hover over the each of the graphs, we can see the state names along with the total insurance transaction. And let's make it a little bit more. It is changed. Tamil Nadu. This is, and here it is case 4. And in case 4, as we see, two case studies are there. So here one and here another. Again, it got hanged. Sorry. That. In case 6, case study 6, insurance engagement by size. Here also we can just adjust some and adjust the bar and then just visualize the state names along with the total insurance amount. We can just, and this is the last case, that is case 7, and it shows the top states, 10 states by transaction values. Like that, it was the final insight from the PhonePe data. Like find like number like the top 10 states by transactions and values. Like this is the entire thing, like total transaction and total transaction values, and here are the statements. So we can also download it, but I'm not just downloading because the computer is already hanging. So yeah, that's all about the presentation, and I will love to end my presentation here. Thank you. দাঁড়াও।